Hello everyone, and thank you for joining this talk. My name is Marais Neethling, and I'm the Principal for Artificial Intelligence at Synthesis Software Technologies. Before we start, I just want to tell you about Synthesis Software Technologies and our intelligent data team. Synthesis is a trusted software development company in the financial and retail sectors. We are also the largest AWS Advanced partner in Africa. Our intelligent data team comprises data engineers, machine learning engineers, and data scientists. And along with our AWS competency, we are well positioned to build end-to-end machine learning pipelines for our clients. How many times have you sent an email with an important query to a service provider and you expect it to be answered within minutes? And how many times did this response come back in minutes? Or how many times did it come back in hours, or perhaps days? Or how many times did it come back at all? Certainly, I think the expectation to be answered quickly is universal. And a lot of times that expectation is really dashed. Just last night, I had an experience when I emailed a small online business with a query about my shipment. And I received a response within minutes, and this was 8:30 at night. This was obviously a great customer experience. And this customer experience is something that larger corporates would definitely have to compete with. So I think you might be familiar with the concept of inbox zero. That state where your inbox has no unactioned emails left in it. For a lot of us, this is probably a dream. And some of us might even reach that. So to investigate this phenomenon, I conducted a snap poll amongst my colleagues. And I've asked them to send me a snapshot of their current inbox state. And this, ladies and gentlemen, is the results. As you can see, there are clearly two categories. There are those people that manages to keep to inbox zero, and then the majority that lets the unread emails spiral out of control. Would you believe me when I say that corporates and institutions also suffer the same problem in their collective business process email inboxes? Companies are either inbox zero type of companies or they're not. And I think everyone here might agree that all companies should strive to be inbox zero companies. And why is that? Well, it's simple, of course. It comes down to a great customer experience. And you want your customers to see that you're responsive to their queries. So recently, Synthesis was fortunate enough to help one of our customers become an inbox zero type of company. Let's have a look at the business process and the requirements for this use case. This diagram shows a simple business process where an email arrives in an inbox, in this case, insurance at Nedbank. A pool of operators reads the emails and picks it up and creates service tickets on a backend system for each email. They need to decide if this email is related to an existing policy, a claim, or perhaps a complaint, and route it to the correct team at the backend. Along with each service ticket, various attachments need to be categorized and attached to the ticket. This means the operator might have to interact with multiple backend systems in order to complete the uploading of the email. Let's look at the key decisions the operator needs to make during this process. There are 4 data elements that they need to have a look at. First is the policy reference, then the email routing type, the email intent, and the attachment type. For the policy reference, the operator needs to find the policy reference or the claim reference in the email. And then they need to see if it's a valid policy reference by looking it up on the backend system. For the email routing type, they need to decide to which team to route this email to handle the inquiry. They also need to understand the intent of the email. For example, if it's claim related, it could be the lodging of a new claim or following up on a claim. If it's policy related, it might be that the client wants to make a change to the policy, or they might want to cancel the policy, or any other number of changes they want to make to their policy. It can also be a complaint that a customer is submitting. And for the attachment type, the operator needs to understand if this is, for example, an existing policy document or an invoice from a service provider or any number of other attachments. Let's look at the approach we took in solving this problem. Synthesis has a well-established and proven way of approaching large and complex problems. So let's look at some of the highlights in the journey we went through. During the pre-sales phase, we needed to show that this problem was solvable. The client provided us with a small sample set of data, and we built some simple models in RapidMiner to show that the emails could be classified. The models performed well, and the client commissioned the project. We started with a story map. Story maps are great for teasing out the end-to-end business process, for understanding the domain, and working with the client to figure out the MVP that should be implemented. When building the user interface, we knew that we had to make it as unobstructive and supportive of the process as possible, because this unlocks the human-machine synergy, which provides us with the ground truth and training data for improving the models. Now let's revisit that process decisions that the operators had to make and see how we implemented this in machines. Let's look at the policy reference numbers, for example. Policy reference numbers all follow a certain pattern, and a simple regular expression was good enough to find and identify the candidate reference numbers. Each one of these then had to be checked against the back-end system using a simple API call. To classify the email routing type, we built a simple text-based machine learning model based on a bag of words approach. To understand the email intent, we built a similar text-based machine learning model. For the attachment types, we actually used two different approaches. Where text could be extracted, we used the simple text-based model. For documents where we couldn't extract text, we actually used a machine vision-based algorithm with a convolutional neural network. So let's look a bit deeper into the data and the machine learning models we employed. First of all, a short analysis on the data. So as with most of these real-world data sets, the distribution of the classes is not uniform and it was heavily skewed. And so we had to deal with this problem. In the end, we decided to try and only predict the most common classes, and with the rest of the classes confined to a single bucket in the tail called Other. So in this data set, the tail was extremely long and it comprised almost 70 classes. Usually the amount of trainable classes we picked was in the order of 10 only. So this leaves us with 60 classes that the model can't distinguish. But luckily this is not a big problem for us, because the frequency with which these other classes appear is very low and doesn't impact the business process that much. Anything we classified as other will appear in the operator's backlog queue to be classified manually. We then of course had to sample carefully from this training set to ensure we have a uniform distribution during training of our models. There are numerous ways of sampling, and we're not going to go into the detail of which sampling technique we should use. Let's quickly look at the bag of words text-based models we built. All these models was re-implemented in Python so that we could have more control over the models. Let's have a look at the data preparation, the feature extraction we used, and the classifiers. So emails are tricky things to work with. There's a lot of noisy bits in an email which needs to be removed. We also employed removal of non-English words, so matching words with a dictionary. And this means we can't classify emails that are not in English. Another common way of preparing the data is to remove all sorts of common words from the data so that the signal comes through stronger. The feature extractors we employed was TF, IDF and LDA. Term frequency, inverse document frequency, is a robust technique that was also employed in search engines to great effect. And lastly, the classifiers we used was all the usual suspects: support vector machines, random forests, k-nearest neighbor clustering, AdaBoost, XGBoost, etc. We tried all the various classifiers and did some hyperparameter tuning, and in the end we created a stacked regression model based on a few of these best performing classifiers. This gave us accuracies of almost 90% for a lot of the classes. Now let's look at the image-based model we built for the attachment classification. Similarly, we're going to look at data preparation, feature extraction and the classifiers. So data preparation is pretty simple. You need to turn your document into raster image format, and so we basically took snapshots of each page. The feature extraction was done using a ConfNet, basically AlexNet, that was pre-trained on a corpus of documents. For the classifier at the end of the pipeline, we used the extreme learning machine. That's a simple type of artificial neural network with a softmax output layer. Now I like looking at ROC curves and confusion matrices as much as all the other data scientists. But we're not going to look at those things today. We're going to focus on the business process outcomes and the results we achieved in the business process. So first of all, barring any machine learning, let's just look at the process speedups the humans achieved while using the new user interface. The humans were able to onboard emails with no attachments 4 times faster than before, and emails with one attachment 6 times faster than before. And as you work with emails with more and more attachments, the speed up almost becomes exponential. The graph on the right depicts the time it took to onboard emails before and after the process. The green bar represents the time in seconds for emails with no attachments. The red bars depicts the time for emails with one attachment, and the blue bar depicts the time in seconds for emails with 5 attachments. As you can see, the time to onboard any of those type of emails is now less than about 80 seconds. Now adding in machine predictions, and this time reduces even more. One of the features we enabled pretty early on was automated uploading of the emails. So in those cases where we had high confidence, we could straight through process an email with no human involvement to the backend system. Initially, this was done for emails with no attachments. At some point, we switched on straight through processing for emails with attachments as well. And this significantly lifted the amount of emails we could automatically process to the backend. This graph shows that around 30% of emails was processed straight through to the backend. And despite a big increase in the numbers of emails coming through, from April onwards, around 70% of emails was processed automatically. The impact that the system had at Nedbank Insurance, albeit on one email inbox only, was quite significant. They reduced the number of hours that humans spend looking at emails quite significantly. And this obviously leads to a cost saving. It also leads to a customer experience improvement, because the time it takes for customers to receive the responses reduces dramatically. The opportunity for every business is, of course, improving customer experience and reducing your cost by increasing the automation and freeing up humans to do more innovative work in other areas of the business rather than sitting and looking at boring emails. This leads directly to increased employee job satisfaction. At this time, I want to thank Nedbank Insurance for their vision and commitment to this project, and sticking with us through the highs and the lows, as with any project. And I also want to thank my synthesis colleagues for working as diligently as they have on this project and for making it a success. If you want to get in contact with Synthesis or the Intelligent Data team, this is our contact details. After this session, there's also a live Q&A where you can ask us about all the aspects of this project which we didn't cover in the talk. So please stick around and join us in the foyer, in the digital foyer, to discuss this project. Thanks.